Hey kiddos, today we are going to be talking about writing and evaluating expressions. So we're going to focus on our two skills today. The first skill, writing, is going to be taking a composition that's written, real world experience and kind of translating it into something more mathematical. And then the second skill that we're going to be practicing is once we have those expressions written, how do we plug a value in for the variable so that we can get an answer? Okay, so we can evaluate. So our first skill, we're going to be writing expressions. And again, what we're doing is we're looking at a situation and then we're going to be translating that into a mathematical expression. So some of the key words we're going to be looking for to figure out what operation we're using: addition, subtraction, multiplication, division, we've gone over in class. So when you look at these, this is kind of not a comprehensive list, but a list of words that we're pulling from. Okay, so looking at these for examples, we have the first one, a product of 8 and a number. Now remember, when you have product, that is a word that means we are going to be multiplying. And the two things that we are multiplying are going to be 8 and a number n, where n is a variable. So product means multiply. There's two ways we can write this. We can either write 8 and then just the variable n, because remember, when there's nothing in between the number and the letter, it means the operation is multiply. Or we can be more direct and use parentheses like this. And that also means 8 multiplied by n. Both of these are the same. Okay, next one, a number w is decreased by 9. Decreased is a word that means subtraction. So we're starting with our value of w and we're decreasing that value by 9. Okay, the quotient. Quotient is one of those mathematical words that a lot of students don't really recognize, and it means to divide. So we're going to create a fraction here, a quotient of 7 and the number x. So in this fraction, because we are dividing, 7 would be our numerator and x would be our denominator. Quotient again means to divide. And then 24 decreased by the product of 6 and q. So we have two operations going on here in the same problem. We're going to start with a value of 24. And then we're going to decrease that. That means subtract by the product of 6 and q. That means 6 and q are going to be multiplied together. So we're decreasing by a value of 6q. That's a product, so it means multiply. Okay. We're going to look at just a couple more examples. The last examples were very explicit. They had words in there that were really easy to tell what kind of mathematical operation we're going to use. These are more real-world based. We're looking at a situation here, and we're going to turn it into a mathematical expression. So number one, a taxi cab driver charges a base fee of $2 plus an additional 25 cents per mile. Write an expression to determine the fare. So pretty standard. A taxi cab driver charges a base fee, so that's a constant. The $2 is not going to change, so that's what we're going to start with. And an additional, so we're adding this on, 25 cents per mile. So they're adding on an additional 25 cents. And because we don't know how many miles the person's traveling for the fare, we're going to include a variable here. So this is the base rate, which is $2, and 25 cents for every mile that they travel. Number two, the cost to rent a banquet hall is $240. Again, that's a constant. That's a set rate, $240 to rent out this banquet hall. If the cost is shared equally among all the people who attend the event, how much will it cost per person? So shared equally means that we're dividing. We're splitting this cost between a certain number of people. So we're going to be dividing by, and because we don't know how many people are attending, we're going to divide by X. So this represents the $240 it costs to rent the banquet, and then we're dividing that by the number of people who actually attend. Okay. Number three, after Kyler took a road trip, his car had 39,857 miles. If he traveled m miles, write an equation to determine the number of miles he had before. Here, before is a very key word because we're going before. That means we're doing a subtraction. So we're going to take the number of miles that he has, 39,857, And we are going to figure out how many miles they had before they traveled. So we're subtracting the total number of miles they traveled. So 39,857 minus m, that would give us the miles they had before the trip. Okay. Now that we've talked about actually writing expressions, we're going to talk now about evaluating them. So evaluating expressions, super, super simple. We're going to give a value and then plug that into an expression instead of the variable. So here are the directions. To evaluate an expression, replace the variable with another value. So in this example, they're asking us to replace a. Wherever you see the letter a, you're going to replace that with the number 3. So here 7 times a becomes 7 times 3. And again, the reason we put the 3 in parentheses here is because we don't want it to look like 73. So here it's really easy to tell 7a, you're not going to confuse those. 7 multiplied by a. 7 multiplied by 3, it's easier to tell it's not 73 when we use the parentheses here. And then you just do the operations. You add, subtract, multiply, or divide, whatever it's asking you to do. Okay, so we are going to look at a couple examples. So our first set of examples, we're using 2 values. We're going to replace a with the number 5. We're going to replace b with the number -4. Those values are going to go in. So the first one's really easy. We have a plus b. So a is going to be replaced with 5. We're going to keep the plus sign. And b is going to become -4. Now, I've talked about this before. We have 2 mathematical symbols in the middle. We have to combine those to be the operation it really means. A positive and a negative really means subtraction. So 5 minus 4. And when we evaluate, we get the value of 1. Final answer. Okay, second example, we're going to keep the 2. AB really means we're multiplying the values of A and B together. So what I'm really doing is I'm multiplying 5, which stands for A, and -4, which stands for B. And then we're multiplying all of that by 2. Okay, so we can just multiply all these together. 2 times 5 is 10 times -4. And that gives us a final value of -40. Our last one, we are multiplying, and then we're going to be subtracting values. So we're going to keep the 3. The a next to it gets replaced by the number 5. And again, I put it in parentheses so it doesn't just look like 35. We're going to keep the -5, and then b is replaced by -4. Okay. So now we're going to multiply things out. 3 times 5 gives me 15. I have -5 times -4. We got to be careful there. Negative times a negative gives us positive 20. And then I just combine the values. 15 and 20 give us 35. Okay. So 3 really very straightforward examples of evaluating an expression. We're going to use the same values for the next 2, but we're going to be plugging them in to slightly more complicated examples. So here we have a squared plus b squared. Now this is only a little more complicated if you forget what square means. Squaring means that we're multiplying the number by itself. So we're still replacing a with 5. And again, I'm using parentheses so that I don't get confused. Plus, and then b is replaced with -4, and I'm not going to forget exponent on here. So 5 squared means 5 times 5, not 5 times 2. 5 squared is 5 times 5, which is 25. And here we're not going to get confused. -4 squared means -4 times -4, which gives us a positive 16. Okay, we add those values together. 25 and 16 gives us a positive 41. And our last example using these values, a equals 5 and b equals -4. We have 2 a's. That's okay. We're just going to replace both of them with that 5. So we have a 5 in the numerator. We have a 5 in the denominator. And then also in the denominator, we have a b, which is replaced with -4. Now, really easy. I can simplify this by canceling. I have a 5 on top and 5 on the bottom. But that is going to leave our fraction without a value in the numerator. So remember, if there's nothing on top, we cannot leave it blank. It's not a 0 because that would cancel out everything. We're going to put a 1 there. So it becomes 1 over -4. You could also write -1 over 4. It doesn't matter where the negative goes as long as it's only on one of the values, either the top or the bottom. Okay. And now we have our final examples. Here we are going to be evaluating a quadratic. So we have an x squared plus 4x minus 10. That means that we have two x's that we're replacing. And we're going to replace that x with three different values. So our first example, x is going to be replaced with the value of 3. So I'm going to rewrite my expression. I have 3 squared plus 4 instead of x. Again, I'm multiplying by 3, same value. And then I'm going to take away 10 from all of that. Okay. Then we just go through order of operations. We'll do our exponents first. 3 squared is 3 times 3, which gives us 9. 4 times 3 is 12. And that minus 10 just tags along. Okay. 9 plus 12 gives us 21. And we subtract 10 from that. And so our final value is 11. So that means when I plug in 3 into this expression, the value of that expression is 11. Okay, we're going to do the same exact thing now, but instead of 3, we're replacing x with negative 2. So same operations. Okay, I'm going to go in and I'm going to replace every x I see with negative 2 plus 4 instead of x, again, negative 2, and then I'm going to subtract 10. Okay. Negative 2 squared, this is where you got to be careful. Negative 2 squared is negative 2 times negative 2. Negative times negative gives us positive 4. 4 times negative 2 is going to give us negative 8. And then that minus 10 again tags along. So I have 4, take away 8. The 8's bigger, so we're going to have negative 4. Then take away 10 more from that. So if I have 4 negatives and then 10 negatives, altogether I have negative 14. Now our last example, a little different because we're adding a fraction into the mix. We're replacing x with a fraction. Just because it's a fraction, they might be intimidating, but it doesn't mean anything changes about the procedure. We're still going to replace x's. So instead of x, I'm going to write 1/2. Okay, plus 4 instead of x, again, I write 1/2. And then this minus 10 is just going to tag along. So 1/2 squared, you could think about it that two ways. 1/2 times 1/2, which is not hard, is going to be 1/4. Or you could think of it as square the top number, square the bottom number. Either way, you get 1/4. Okay, plus 4 times 1/2 is just half of 4, so that's going to give us 2. And then the minus 10 tags along. Now, we need to add fractions and whole numbers. So first I'm going to subtract the whole numbers. So I'm going to keep the 1/4. And then I have 2 take away 10, that's negative 8. And then I got to change that 8 into fourths because I want to be able to add and subtract these fractions. And I don't want to get a mixed number. I know that would be really easy to get, a mixed number here, negative 7 3/4, but I actually want to get a mixed number. So, improper fraction. So I'm going to have 1/4 minus 32 over 4, just converting that 8 into fourths. And my final answer is negative 31 over 4. Really easy. Okay. And again, I like improper fractions more than I like mixed numbers. So that's why I think this is a more clear answer than it would be if we had a mixed number.